My name is Bob Bingham and I study climate change and interpret how it affects New Zealand, and I report on this through my website called Climate Outcome. The website draws on scientific reports from government agencies and universities and attempts to interpret the research in a way that is quick and easy to understand. Most of the information is related to how climate change will affect New Zealand, but climate change is a global event and we are not isolated from the rest of the world. So the website draws on global reports. The climate is changing, and although the temperature of the world has only increased by 0.5 degrees centigrade, the planet is very sensitive. We have put a massive pulse of CO2 into the atmosphere, so that at 400 parts per million, we have created an atmosphere that the planet last had 4 million years ago, when the climate was 2 to 3 degrees centigrade warmer and the sea level was 25 meters higher. Climate change will have a wide range of impacts, and so I will cover the main points pretty rapidly and without much background science. If you want more detail, you'll have to go to the website. Most of the real action in climate change is taking place in the oceans, away from our eyes, and in an area where we have very poor long-term records, or in the case of the deep oceans, any records at all. The oceans absorb 93% of the heat that comes from the sun, and the oceans also absorb 50% of the CO2 we have emitted. I use this particular chart of the ocean conveyor because it shows the turnover points between the warm surface water and the cold, deep oceans. As warm water in the Gulf Stream moves north, it cools and sucks CO2 from the atmosphere in vast quantities. And when it sinks, it takes this CO2 into the deep. The chart shows the turnover areas in the Southern Ocean, where the cold, nutrient and CO2-laden deep water resurfaces after approximately 30 years. I'm not sure that anyone knows precisely how long it takes for the water that sinks in the North Atlantic to resurface in the Southern Ocean, but 30 years is a commonly used figure. Although the water is relatively cold, it is still storing heat in the ocean's depths, but it is so dark and deep and has incredible pressure that it is difficult to access, and there are virtually no long-term records. We have 3 rovers on the surface of Mars and none in the deep oceans. The abnormal heat and ocean acidity is doing untold damage to a very sensitive system and storing up problems for us when the water resurfaces 30 or 40 years later. These are the indicators that show what is happening in the upper layers of the oceans. In the top chart, the red graphic is called the Keeling curve and shows the increase of CO2 in the atmosphere. The blue graph is the CO2 content in the oceans, and the green is the pH level, indicating changes in ocean acidity. The downward slope of the green line indicates that the sea is becoming more acidic. The lower illustration is of phytoplankton. Phytoplanktons absorb CO2 for their structure and create oxygen for us to live on in vast quantities. These little chaps provide half of the oxygen that we breathe. Many types of plankton have calcium carbonate structures, and calcium carbonate shares the typical properties of carbonates in that it reacts with acids. As the structures of the plankton corrode, they release carbon dioxide, so that instead of storing carbon on the sea floor, it is released again into the environment. Between 1751 and 1994, surface ocean pH is estimated to increase from approximately 8.25 to 8.14, representing an increase of acidity of almost 30%. All ocean creatures with a calcium carbonate structure will be devastated as the oceans become more acidic, and reproduction rates of almost all aquatic creatures will suffer. The base of the marine food chain is plankton, and these are consumed by krill. If we lose the krill, the whole of the food chain of the oceans is cut off at the base, and we will be in big trouble. As the oceans absorb CO2, they become more acidic, which damages aquatic life with a calcium carbonate structures, such as corals, mussels and crayfish. This is already making an impact in mussel farms in the United States Pacific coast and on the coast of Brittany in France. Seawater does not have the daily temperature variations that the atmosphere does, and so fish and other aquatic life are much more sensitive to temperature changes than we are. Changes in the ocean temperature that are already happening are causing fish to move to areas with temperatures they are more accustomed to, primarily away from the warm waters that have become even warmer towards what used to be cooler areas but have now become warm. In general, they are moving away from the equator and moving both north and south. The ocean sea levels are steadily increasing, and they have increased by 100 millimeters in 100 years, about 4 inches, but they are slowly accelerating. And as a result of this, we're going to have to think very seriously about sea level rises in the future. Greenland sits between 60 and 80 degrees latitude and is susceptible to warming. The surface is melting in the summer, and the meltwater forms warm pools which cut a hole in the base of the lake, and then the warm water plunges into the deep ice. The water can either lift the ice so that the glacier slips towards the sea, or it stays deep in the interior to warm the ice. The end result is that this 3-kilometer thick ice sheet is becoming full of holes, and the danger is that it becomes rotten in its core and may collapse very quickly. The worry here is that scientists can calculate how long it takes to melt a big block of ice, but there is no way of forecasting a sudden collapse of this nature. West Antarctica is different in that it is a series of islands holding massive amounts of ice together and is very susceptible to warm water melting the ice from below. This melting is eventually causing a collapse of the ice shelf and a dramatic speed up of the huge land-based glacier flows that are currently being held back. The Larsen ice shelves, A and B, have disintegrated, and although Larsen C is still stable, it has to be suspect. The Pine Island and Thwaites glaciers are in the early stages of terminal decline and are being carefully monitored. Nobody knew that the Larsen was going to collapse. Nobody knows how long it will be before the next major collapse will take place, but it was a lot closer than we thought it was 10 years ago. When the ice melts, we have to consider the consequences of rising sea levels. 11 of the world's 15 biggest cities are only 1 meter above sea level. If you see the infrastructure and farmland that disappears with just 1 meter of sea level rise, you do not need to look at larger sea level rises of 20 meters or so. Big areas of the UK, Holland, Florida, and the United States, Gulf of Mexico are hard hit, and the economic consequences of huge areas of land are going to be disappearing, are going to be massive. The lower map shows the loss of massive amounts of farmland in California right up to Sacramento. Methane is a very powerful greenhouse gas and is 72 times more powerful than CO2 over 20 years. And its proportion of the atmosphere has grown 150% compared to CO2, which has only grown 40%. There is a massive amount of methane locked up in frozen vegetable matter in the tundra, which is slowly warming and releasing methane to the atmosphere. Methane clathrates is methane held on the seabed by a combination of pressure and cold water. But as the water warms, this is being released and is bubbling to the surface. Just to emphasize methane's importance, it has been calculated in a previous warming era, when the world's temperature increased by 10 degrees centigrade, there was not enough CO2 available to raise temperatures more than 5 degrees centigrade, and it must have been bolstered by methane to reach the 10 degrees centigrade rise. This is the United States Academy of Sciences forecast for food production in a warming world. As the temperature goes up, the food production goes down. There are a variety of reasons, but flood and drought are the main problems. The forecast is for wet areas to get wetter and dry areas to get drier. And just as important to farming, there is expected to be a big increase in crop pests and in disease. This is much the same information from Europe. The map at the top is the Institute of Environment and Sustainability, which is the European Union Food Production Authority, and the table at the bottom is by the World Bank. Both give essentially the same figures. The map shows a 20 to 15% drop in Spain, 15 to 5% in France and the Mediterranean countries, and some gains up north. Essentially, the losses are caused by heat and drought. The forecast is the same for almost every country in the world. As the temperature goes up, food production goes down, and rising sea levels will flood farmland and water supplies with seawater. The last time the world had today's level of 400 parts per million of CO2 was 4 million years ago, and the trees and plants at that time were adapted to the climate that went with it. Those trees have taken thousands of years to evolve to match those conditions. The trees we have today are adapted to a CO2 level of 280 parts per million and a climate about 0.9 of a degree cooler than we are now, and are rapidly going into conditions 2 degrees centigrade warmer and with dramatically changed rainfall conditions of either drought or flood. All around the world, species of trees are dying. What seems to be happening is that the trees become stressed by drought or heat, and in its weakened state it is overcome by pathogens, which could be beetles or fungus. If the tree was in good health, it could survive this attack. We can expect to see much larger numbers of trees and other plants dying in the coming years as the temperature steadily increases. There are a lot of misinformation about climate change, but for real information I find it better to go to the main government websites. In America, that would be NASA, who have all the satellites, NOAA, who do all the weather forecasting and monitor the environment, and the Environmental Protection Agency, who looks after fresh water and gases in the atmosphere and pollution and that sort of thing. In Australia, there is CIRO, which is the Australian Environmental Agency. In the UK, there is the Met Office, which handles all the weather forecasting and climate change as well. And in New Zealand, we have NIWA, who are the main scientists for the New Zealand government.